So for the next one, we will actually talk about rotation, that how we can actually rotate an image in a computer screen. So before that, let's see that why we actually use matrix. So as you can see, matrix are more convenient organization of data. It's more efficient in processing and enable the combination of various concatenations. So basically, if you use matrix for the calculations, for the multiplications, it becomes easier and data becomes easy to handle. You don't have to select point by point and single point and you have to transform it. You can take the whole image as a matrix and you can then multiply with another matrix and just print the result. So this actually becomes very easy. So simple. First, we start with matrix addition and subtraction. So if we have a matrix A and B and there's another matrix C and D, if we add those matrices, it will be A plus C and B plus D. So there will be one column and two rows. Here there is one column and two row, one column, two row, and the result will be one column and two row. Next one is that matrix multiplication. So let's assume there is a rule in the matrix multiplication. I think you know that whenever you're multiplying two matrices, the row RC, the row and the column have to match within these two. So here, what is the number of columns we have? So we have one column and two row, and in this one we have two columns and two row. So the row number in here is 2 and the column number is here is also 2. So that means we can multiply these two matrices. So if we multiply these two matrices, the result will be something like this. I will not discuss how this calculations is being done. Okay, if you are still not clear about how matrix multiplication, there are videos in the YouTube. You can just go and watch those videos. Okay, so our focus is the next one. Let's assume we have an image A, B, C, D and X, Y. And then if we multiply those images, we'll get something like this: AX, VY, CX is DY. So we will use what is called column vector representation for a point. That means each point XY will be represented as a column. So if you have a point like 5, 5, it will be presented like this way. So why we're actually doing this? Okay, so one advantage is this. Let's take a let's go to our whiteboard. So let's assume that we have a this is a monitor, and in the monitor we have a picture like this. Let's assume this is a picture. Okay, so this is a picture. We have to zoom or we have to apply a filter in this picture. So you see in this picture, all of this are actually, this is a collection of points, right? We can agree that this image is a collection of points. So we have a one point here, we have another, we have all of this are actually different points. All of them have different axis, X and Y values. Okay, so if I actually randomly take different points of here, okay, what I can do, if I actually just apply the matrix, the scaling factor or the translation factor in all of these points, is eventually I will get the new image. So that is simple as that. You have an image, you select all the points for this image. How many points should you have? It might have 100 points, might have 1,000 points, might have a 10,000 point. Sorry. So what you will do, you will take all the points, you will represent them as a column vector. So what is a column vector? You see, this is a point XY, and then you will multiply it with the matrix, the transformation matrix. The transformation can be scaling, the transformation can be translation, the transformation can be rotation, whatever that is. You will take one point and you will multiply it with the matrix, and eventually you will have a new image. So I will actually show you practically how it is done, but let's for now cover the theory. So here is a little bit about rotation. So we have to actually cover a trigonometric concept for the rotation. So first of all, what does rotation mean? Rotation means that suppose this is a P point, you now don't want to actually translate the point, but you want to actually rotate the point. So I hope you understand the difference between rotation and translation. So rotation means the reposition of all points in an object along a circular path in a plane, and translation was rotation, sorry, reposition in an sorry. So translation was reposition in a straight line, okay, and rotation is reposition in a circular line. So that you see this is a circular path, so you're actually rotating in a circular path. Now there might be a question, sir, why you are actually going through all this trouble? Why not just do it in a straight line? You see, sometimes we have to actually do pictures like this. Let's assume, where is it? Here. So this is an example. So suppose this is your object, okay? And what you want to do, you want to actually rotate the object and bring it to here. So how the rotation was done, as you can see from this picture, each point here. So this point, okay, let me take a marker. So this point you see here, this point is actually being translated to here. And this point, you see all these points you can see are visible one by one. So let's see whether you can find out. So if I can compare this one with this, so where is my first point, the second point, the third point, and the fourth point? So all of these points, we are sure that they are actually here somewhere. But you cannot actually say for sure, so this point is this point, or this point is actually this point. So the translation is actually a little bit complicated. At the same time, it's actually hard to do. So one simple example of translation can be here, this one. Oh, let me clear it. So you see, I will actually play the slide. Let's see whether you can actually see it. So did you see how translation happened? Let us go back and play it again. So the initial object was here, and this is the initial object, and after doing the translation, this will be the final object. So let's see how the translation happens, okay? So again, let me play it one more time. So you see what's happening here? The object is being transferred or transformed in a circular way. So let's play it again. You see, this is actually not a straight line. This is a circular way. And there are two types of rotation. The rotation can be positive rotation. That means anti-clockwise, the counterclockwise. And it can be a negative rotation, just like the clockwise. Just like you have learned in trigonometry, that if you go to the left, it's a positive angle. If you go to the right, it's a negative angle. So here, for the one final time, so this is how the rotation is being done of the object. So we know how rotation actually looks like. Now let's see how rotation is being done. So before that, we have to cover some basic trigonometric equations to make things easier for you. So here, let's start with this one. We have an object that is P. Okay, we have a point Pxy. This is the X and this is the Y. So this is X and this is Y of Pxy, and this is R. So first we will apply the rule of cos. So if this is the angle is phi, so the cos phi will be the X, that is the base. We know that cos theta is equals to base by here, this. Sorry, not this one. I forgot what is the English of otibhuj? Do anyone remember what this is called? Okay, anyway, so we understand this. Okay, so this is actually let's call it for now, let's call it otibhuj, okay, in Bangla. So this is R, that is our otibhuj, so base by this. And then we have sine. So basically,
so hypotenuse.
Yes, that's why I was writing H. Thank you. So hypotenuse is H. So then we have this sine. Okay, so the sine is, we know the rules of sine is basically our height, that is Y, the perpendicular height, and then the hypotenuse. So first we actually wrote this two for cos phi and sine phi. So we have X by R. X is its base here, and R is the hypotenuse. And then in the sine alpha, we have this perpendicular Y, and then we have the hypotenuse R. Now what I did here, then we just change the sign. So X actually becomes R cos phi and Y becomes R sin phi. So I hope this is actually straightforward, clear to everyone. The next, go for the next. So we know, so then what we did, we actually created another point, that is Px x prime y prime, and then we calculated same for Px prime y prime. But now you see this time the calculation is a little bit difficult. Okay, you see why this is difficult? Because the angle is theta. So basically we have now a new angle, cos theta plus phi plus theta. So we have this phi angle and this is the theta angle. So if I want to calculate the value of cos phi plus theta, it will be x prime. This is the x prime, and r. Again, this is the hypotenuse. Okay. So this way, first we find out the value of x prime, just the same way we have find out the value of x. So x prime equals to r cos phi plus theta. And then we apply another trigonometric equation, that is the rule of cos theta, so cos a plus b. So cos a plus b is equals to cos a into cos b minus cos a, sorry, sin a sin b. So we applied that equation, and from there, what we did, we actually replaced the values of 2. So you see here, the r cos phi can be replaced by x, and here the r sin phi can be replaced by y. So this way we actually replaced this 2. So this is very basic. We first calculated the using we have first used the equation for the trigonometric cos theta and sin theta, and from there we have first find out the value of x equals to r cos phi, y equals to r sin phi, and then again we applied this for this point as well. So why we're taking these 2 points? Because this is where we will start and this is where we will end, and soon you will see how it works, don't worry. Same goes for the sine. Okay, we have applied the same equation. We have found the value of sin phi plus theta equals to y prime by r, and then from that we have calculated y prime equals to r sin phi plus theta, and gradually we have calculated y prime equals to x sin theta plus y cos theta. Now what is the actually the implementation of this? So if I go to the next slide, you can see that these points, okay, instead of writing x prime equals to x cos theta minus y sin theta, we can write px p prime x equals to px into py. So basically we have replaced x prime with px prime. So you see this is px prime. We have replaced x with px. We have replaced y with py. Same. We have replaced y prime with py prime, and x with px, y with py. Very basic. Okay. And then we can actually, if we use a matrix, instead of writing like this, we can write directly p prime equals to r into p. So you see, this is the advantage of using the matrix. So instead of writing all these equations, you can just write p prime equals to r into p, where the value of r is cos theta minus sin theta into cos theta. Now the question comes, why this is cos theta minus sin theta into cos theta? The answer is right here. All comes from simple math. You see, the first one here is cos theta. The second one here is sin theta. The first one here is sin theta. The second one is cos theta. So this cos theta comes here. This sin theta comes here. This sin theta comes here. And this cos theta comes here. And where does this minus came from? Okay, I have made this picture actually more ugly. So I hope you understand this. This one comes here and this one actually comes here. And you see, this minus actually comes from here. So every time we have a minus, it will also join here. So you see, all the equations that you've seen here is actually very simple trigonometry, nothing complex. What we did, let me repeat one more time. We first we have took just one point, one single, very simple, one single point. This is our source. The orientation, the coordinate of this point was x and y. Okay, and then x equals to, we have calculated the angle was phi, so cos phi equals to x by r, and sin phi equals to y by r. From there we have calculated x and y. Same way we have calculated x prime and y prime. So we have this x prime and y prime. So this was the initial x prime, this was the initial y prime. Then we have replaced this r cos phi with x and this r sin phi with y. Same way, this is what we have done. This is step number 1. And then we have replaced, here we have applied the rule of cos a plus b. Here we have applied the equation of sin a plus b. And then we have formed a matrix more like this one. So instead of writing x prime equals to x, we have written px prime equals to px, and instead of y, we have written py. So that we can actually take this matrix from where p prime equals to r into p. What is p? P is xy. What is p prime? P prime is x prime y prime. And what is r? R is cos theta minus sin theta into cos theta. And where did it come from this? Basically just from this equation. This cos theta is come from here. This minus sine theta is actually becomes minus sine theta. This sine theta comes here and this cos theta comes here. Now what is the advantage? Now we will just see the real example that I have telling you all about. You see, let's assume that you have a point P. So this is a point P. The value of the point P is 5, 1. And you want to rotate this P prime, sorry, this point P by 90 degree. So basically you have a point P and you want to rotate the image by 90 degree. Now you see, this is 90 degree. That means there are two ways you can do. You can go 90 degree in this direction. You can go 90 degree in this direction, right? So which one you will go for? Okay, you say this is a positive angle. So we know that if the angle is positive, we go for anti-clockwise. So clock goes in this direction, anti-clockwise goes in this direction. Okay, and if it is a negative angle, we'll go to this direction. That means the clockwise. So if you are confused about how clockwise, anti-clockwise work, one more time, clockwise means that as the clock actually goes on the same direction, it will be for negative angle, and anti-clockwise means the opposite of clock. This will be considered as positive angle. Now we want to apply this 90 degree rotation to a 0.51. So how it will work, the mathematical example. So let's see how mathematical example actually work. So first what we have to do, we have to write this rotation matrix R, that is cos theta minus sin theta into cos theta. Where did we get this rotation matrix? Just from the previous slide. The rotation matrix is cos theta minus sin theta into cos theta. Okay, and then this is, you see in this slide we have told about that each point will be converted to a column vector. So you see each point will be x and y. So using the same formula, we're using 5, 1 is converted to xy. So it will, if I multiply this two, it will become something like this: x cos theta minus y sin theta, x sin theta and y cos theta. Then we will put the value of x and y. So as you can see, x is 5 and y is 1. And then just using your calculator, you can just find out the value of, because we are doing a 90 degree notation, so theta will be 90. And then you can find the value of, this will be your new point, minus 1, 5. So that means if I apply a 90 degree notation to the point 5, 1, the new orientation will be minus 1, 5. So let's just draw the picture. Let's see whether you can understand. So let's assume that we have a, let me clear it. So let's assume we have a point here. This is our x-axis, y-axis. So we have a point here. The point is 5, 1. Okay. So let me check back whether it was 5, 1 or 1, 5. This is 5, 1. Okay. So the point was 5, 1. So 5, 1 will go like this. This will be 5 and 1. So the point will stay somewhere in this region. Okay. So let's assume this is 5, 1. So what I did in this point, I have applied a rotation of 90 degree and it became minus 1 and 5. So where is minus 1? Minus 1 is somewhere in this region. Okay. And 5 will be in this way. So that basically means the picture will come here, minus 1, comma 5. So if I rotate, this will be our new image. In a circular path, this point with 90 degree notation will come here. Now, the question you might ask, sir, why we are actually going through all this trouble? Okay, because whenever you actually rotate an image, that we actually use every day. Okay, whenever you take a picture, you actually rotate it to left, rotate right. You can actually turn it in different angles. Meanwhile, in the background, all this calculation is being done. Here I have shown you for one single point. Then I will show you for a shape, that how the rotation is done for a shape. And finally, I will show you how it is actually done for an actual image. So then it will actually become interesting, because the things we actually learn in this graphics course are actually we use every day. Because now, thanks to the availability of gadgets, everyone have a mobile phone or laptop or a computer, and everyone actually use different graphical interfaces every day. Whenever you drag and drop, we use translation from one point to another. Behind this screen is actually highly optimized version of transformation translation going on. So again, same way, if we apply, this is a, suppose this is a shape image. If I apply rotation in this, it will actually transform here. So all you have to know, all you have to do is just take an image, just multiply with the matrix, and then within 1 second, you will have the calculation. And we know that computer actually very good at doing calculation, right? It actually can do billions of calculation in 1 second. That means doing all this graphics work is actually like a piece of cake. Okay, it can do this very easily. So you see all this translation that we can see in the screen, they're actually done very easily. You can shift houses, you can shift places very easily. So this is all about the rotation, and I will finish my today's class here.